Welcome to the F+L Webcast. My name is Vicky Denton, and I'm your host. Our guest today is Jim Simnick. Jim is the chair of ASTM Committee D02 and Petroleum Products, Liquid Fuels, and Lubricants. Welcome to F+L Webcast, Jim.
Vicki, thank you. And thank you for this opportunity to be on this webcast with you and talk a little bit about ASTM and what we do in the Committee D02, as you just cited. So it's great to be here.
Thank you. So, Jim, let's start asking you about yourself. You have a long career in the oil industry. Tell us how it started and what your journey was like.
Sure, Vicki, be glad to do that. And I'll try to keep it short and concise. That's just pertinent to our webcast today. But when I finished my PhD in chemical engineering at Purdue University, I went out and started interviewing for employment, and I was lucky enough to find a job with what was then the Amoco Corporation, and I wound up working in the refining technology department. So having a degree in chemical engineering, advanced degree, that made sense to start with technology. And that has been where I have spent just about all of my career, at Amoco, and then later BP when Amoco merged with BP. So I spent about half of my career in the refining space, studying refining technology, particularly focused on a process called catalytic cracking, which is the biggest gasoline maker in a refinery. And then I wanted to be a little bit closer to the customer, the people that buy our products. And so I had a career change and moved over into the fuels technology department. Spent a little bit of time in our marketing department trying to explain technology to marketers. That was an exciting event. And then moved up in both management and senior technical roles within the company. Went through the merger with BP in 1998. And when COVID hit, as you know, people stopped driving and stopped flying, stopped using energy products. And so there was a severance offered. And although I wasn't ready to stop working because I really liked what I did, I took a severance. And then I started Simnick Consulting. And so I've been doing consulting since. Let me talk a little bit about my role at ASTM. So I think it was back in 1995. Our fellow at Amoco that was representing us at ASTM grabbed me by the shoulder and said, "Hey, Jim, we're going to go to ASTM together. And I'm going to teach you about how to represent Amoco at this ASTM meeting." So I had no idea what I was doing. And I have to confess, after the first meeting, I still had no idea what I was doing. But I spent quite a bit of time representing Amoco and then BP at ASTM, particularly in the fuels areas, especially focused in gasoline. And I was offered the opportunity to take officer roles within the ASTM organization, both at the subcommittee level and then at the main committee level. I also was honored with an opportunity to spend time on the board of directors for ASTM, and that was a 3-year commitment, and we did that. And my current role is chair of the ASTM's largest committee, which is the D02 Committee on Liquid Fuels, Petroleum Products, Liquid Fuels, and Lubricants, as you mentioned at the start of the podcast. And so it's been my honor to lead our group and the subcommittees and all of the good work that we're doing at ASTM.
So describe what ASTM's role is in the world of energy. What does it do?
Sure, Vicki. Well, let me be a little bit more broad about what ASTM is. And ASTM originally started as the American Society of Testing and Materials. And way back when, it was decided that people should really have a standard. We should be organized and have quality standards for the things that we use in our lives. For example, concrete, steel, um, um, gasoline, aviation fuel, heating fuel, all those different types of things should have a standard. They're made to a certain minimum quality so that consumers and purchasers and buyers can depend upon the products that they're using. And so that's what really was ASTM was all about. Now let's focus in on the D02 committee. ASTM has many committees, but the D02 committee is the one that's focused on the liquid fuels, the petroleum products and lubricants. And so we have several committees that are focused in on fuels, for example, jet fuel, gasoline, diesel fuel, and heating oil. And these focus in on those products and they develop standards, minimum specifications for all of those products to ensure that they're fit for purpose and they're going to work in the equipment that they're designed for. We also have subcommittees that develop the test methods that allow us to check the quality of these fuels. So we have folks, mostly chemists, working on test methods like to do elemental analysis to check the hydrogen content or the carbon content, that type of thing, or to do other types of analyses of these products. And so that way we can actually, if we have a specification, it's also important to tell us how do we test for those properties in that specification. So that's what these test methods do for us. And so we develop all those standards on a consensus basis. Anyone can join ASTM and participate. You can vote at the committees and vote on these standards. If there's something you don't like, you can vote negative, and your negative vote has to be adjudicated. In other words, the committee working on that particular standard has to go out and understand what your negative is and see what they can do to address it and change the standard to your satisfaction. So everyone's vote counts, and everyone gets a voice. And so it's a very powerful committee that develops standards for all of us. And like I said, it's not just the fuels and lubricant standards. There are standards for amusement rides. There are standards for personal aircraft, drones. There are standards for additive manufacturing, all kinds of things. And so ASTM is a very one of the biggest standards organizations in the world. I'll just say that.
And the reach of ASTM goes beyond the United States. Is that correct?
Absolutely. So these are international standards used by many countries across the globe. They use the test methods. They can adopt the entire standard or pieces of the standard. It's important to note that ASTM does not enforce any of these standards. It's really up to authorities that have the jurisdiction. For example, state inspection groups that may be part of the Department of Agriculture frequently, they will adopt an ASTM standard as their minimum requirement, let's say for gasoline. So all the gasoline in the state has to be made according to the ASTM standard, which is D4814 for gasoline or D975 for diesel fuel. And so when an authority can take the standard and put it into their regulations as legal requirements, that gives it the teeth that makes it a requirement. ASTM by itself does not. But many countries across the globe adopt ASTM standards. We have many participants at ASTM across the globe working with us to help develop these standards and bring in their needs and requirements from their countries to make sure that we have robust and comprehensive standards that will suit people all across the globe.
And you also collaborate with other similar organizations, right?
We do. one of the biggest organizations is ISO, um, and there are collaborative efforts between ASTM and ISO, as well as other standard organizations. There's the Energy Institute in the UK, and with the Energy Institute, we have joint standards. So the standards are technically equivalent, which means that you can either use the EI standard or the ASTM standard. The stamp of both organizations is on both of these jointed standards. And so we cooperate, greatly with other standard organizations. ASTM also participates and is under the umbrella of the American National Standards Institute, ANSI. And ANSI makes sure that these standards are developed in a fair and balanced manner. There's no over emphasis by the producers of this particular material that can overwhelm all the other interests. And so it's called a balance, and ASTM has to require a balance, particularly when they're working on standards for fuels and lubricants, specifications. And so those committees have to be balanced in terms of their voting.
Yeah, when you say balance, you mean producers and users. Is that right?
I do. There's different classifications, Mickey, as you just mentioned, but there's one additional. It's called, if you're not a producer or user of the material, then you're a general interest. And so there's those three categories. There's another one called consumers, but there's not too many of those. For the specification committees, we have to have a balance, like you said. There can be no more producers than there is the sum of all the other groups. So it has to have a balance when we go to vote.
That's really tough, isn't it? Because there's going to be always more producers in the room.
Well, not always. So you'd think so, but there's a lot of general interests. For example, in the committee D02, we have state regulators, federal regulators. We have laboratory test laboratory representatives, and then an independent consultant like myself. We can all be general interest. Users tend to be the people that make the engines that the fuel goes into, and for automotive, for gasoline, the usual suspects. We have General Motors, Ford, Stellantis, Honda, Toyota. They're all the user members of that committee. And so, Vicki, there are plenty of non-producer members in most of the committees.
Yeah, and correct me if I'm wrong, Jim. A while back, I remember attending Subcommittee A on gasoline, and there was talk about providing more voting power to users, to OEMs in particular, because, for example, in the United States, you really only have 3 OEMs, right?
Well, you may have, yeah, that may have been true back in 1950, but now all these companies are certainly international. I mean, Honda, Mercedes, BMW, Toyota, all manufacture cars here. And so, really, you have all those manufacturers that are representing their interests in the United States as well as worldwide. And so, there was years ago there was a balanced voting system in that committee, but that has since been removed. So now it's just like every other committee, one person for one vote.
Yeah, so I guess I guess that was the days when there were a lot of contentious issues within Subcommittee A.
Yes,
Obviously, a lot of changes have happened. It's really tough when you're talking about specifications. It's I've sat in this subcommittees, watched a lot of the negatives being how would you say adjudicated, and
yes.
This can take a long time. I mean, the consensus process is not an easy process.
No, it's not. It's slow, but I like to think it's deliberate. and we're accurate. So you don't want to rush into a specification. It has a lot of impact in terms of its, the supply that's available, the manufacturing cost of the material. As you might imagine, as the specifications get more uh, difficult to make, fewer manufacturers may be able to make that specification. That can reduce supply and increase cost. So it's a balance. Like many things, it's a balance. You want to have a fuel that's fit for purpose or a lubricant that's fit for purpose, but you want to have it available at a reasonable cost. And so, we have to balance the two. And, that's what ASTM is all about.
Yeah, and
Finding that sweet
in
spot.
some countries, they're not even available. But let's talk about one specific topic. I think
Sure.
it's really very interesting how D2 is evolving today. So in the past, when we talk about fuels and lubricants, we're talking about hydrocarbon-based products, but that's no longer true today. Like, for example, in Subcommittee J on jet fuel, right? Jay just had a meeting in April in Brussels, and there's I'm not sure if you call it a task force or a section on emerging fuels. And these
Yes.
fuels actually are not hydrocarbon based. So tell us, Jim,
Well, they're not, Vicky, they're not petroleum based.
they're not
They are
petroleum based.
they are hydrocarbons, but they're not petroleum based. You're right.
Okay, tell us a little bit about what's going on today. And when we're talking about sustainability, circular economy, it's really changing the composition of the products that D2 has to deal with on a daily basis.
That's absolutely true. So it's a brave new world. I'll just say that. And so, especially for aviation, it's difficult to try to electrify the planes that we fly on, simply because weight is a major factor in the batteries that the planes would need to store in order to propel the engines. And weight is precious in an airplane. So people are people are looking at how do we develop low carbon fuels, hydrocarbon fuels that will result in lower net greenhouse gas emissions. And so that's what that whole section in the aviation subcommittee is all about. I will say that this also extends to the other fuels. So ethanol is a big part of gasoline in the U.S. I would guess it's in 96% of all of our fuel. Likewise, biodiesel and renewable diesel now are a big piece of diesel fuel as well as heating oil. But in the aviation space, safety is the key, right? And now we're moving into jet fuel that's not made from petroleum, but instead made from other materials using different processes. It's still a hydrocarbon kerosene, paraffinic kerosene type material, but it's made from different resources. And so the people that make the engines and the people that put the engines on the planes are all focused on safety, as they should be. And every time we're flying at 30,000 feet, I'm glad they are. But we also want to have a lower carbon impact in the flights that we make. And so that's what this is all about. We're trying to find a pathway to take these non-petroleum products, recycled plastics, municipal solid waste, tree trimming, sawdust, those type of things, and through chemical processes, turn them into paraffinic kerosene jet fuel. And so the learning curve is tough. The people that make the engines in the planes are uncertain that there's things in the fuel that we don't know about that would cause problems. And so we're being very careful and deliberate in how we step through the processes to make these approvals. But we're making progress. We now have, I believe it's 7 or 8 pathways to turn non-petroleum material into jet fuel. And so, Vicki, you're right. It's really a change, and that's what the meeting in Brussels that both you and I were at was all about. The first day was a seminar on the status of synthetic jet fuel, and the next days were the regular meeting of that subcommittee, the D02J subcommittee, which is part of the D02 overall committee.
So,
But
Jim,
they
you
met in
mentioned
Brussels. Yeah,
one terminology,
yeah.
low carbon. Does ASTM have a definition for low carbon fuels?
No, I don't believe there's a definition for low carbon fuels, and in fact, that is pretty much the purview of the regulators. So, for example, the European Commission defines what low carbon is. The U.S. EPA in the states defines what low carbon is and is eligible for low carbon credits. Um, and so they typically use life cycle models that look at from the beginning to the end of the material and the engine that it's used in, and what is the carbon impact compared to the standard that's being used today, petroleum-based jet fuel. And you look at the carbon emissions from those two, and if you have a significant percentage reduction, then you can call it low carbon.
So, within the EU, Jim, would you have any idea what the threshold is that's being used by the EU to say a fuel is either low carbon or not low carbon? How much
Uh,
reduction do they have?
yeah, I'm not exactly familiar with the EU criteria. Um, I would be guessing if I gave you an answer, and I don't want to do that in our interview. For the U.S., it's anywhere from 30 to 50% reduction, depending upon the fuel and the classification of the what I would call the RINs, Renewable Identification Number, is what the U.S. EPA uses to identify and renewables, and those are classified using this life cycle model and determine the amount of carbon reduction compared to a standard fuel made from petroleum.
Yeah,
And so,
let's
yeah,
talk about ethanol and diesel because they've been in the marketplace for much longer.
many
Ethanol,
years, yes.
yes, for ethanol, how much reduction is there? And for biodiesel, or does that really depend on their feedstocks?
You just answered your own question. so, so Vicky, it depends greatly on your entire life cycle analysis. How did you start making the ethanol? Did you start? Typically we make it from corn today. Corn is harvested and then sent to a biorefinery where it is fermented and turned into fuel grade ethanol. The fuel grade ethanol is denatured to make it non-drinkable, and then that's the material that we use to blend into gasoline. Typically at 10%. Some cases there's 15% being blended. In the biodiesel case, we typically take soybean oil, plant oils, and it's a esterification process. They react that with methanol over a catalyst, and that creates this fatty acid methyl ester. They call it FAME, and that's the material that we blend into diesel, and we call that biodiesel. And that can be blended anywhere from 5 to 20%, depending upon how much biodiesel you want. Another way to take the oils is to process them in a refinery, and you can hydrotreat the oils along with petroleum if you want to do something called co-processing, and then you can turn them into the same hydrocarbons that are in the petroleum diesel. And the only way you can tell them apart is by looking at the carbon isotopes. Is it a carbon that comes from a dinosaur, petroleum, or is it a carbon that comes from a cow?
So, question, Jim.
Yeah.
Biodiesel, if you were to take the same feedstock, convert it to biodiesel versus you do hydrotreating, and I believe the terminology we use here is HVO, isn't it? Hydrotreated vegetable oil?
If you use vegetable oil, it would be HPO. Yes.
Okay.
And so
And there are some plants around that are actually doing this now. Um, in terms of in terms of carbon savings, what's the difference between the two?
well, carbon savings it gets very specific, and I think you alluded to that answer a little bit earlier. I'll give a good engineering answer: is it depends, and it really depends upon what's the source of the oil. Did you extract the oil by squeezing soybean seeds? Did you get the oil from uh, rendering fat at a meat processing plant? Is it recycled, cooking oil? All those different sources have different carbon impacts. And then you have to look at how much energy do you spend transporting the oil and gathering it and sending it to the refinery. And so when you do all that accounting, that kind of gives you a sense of how much carbon savings you have versus using petroleum to make that diesel fuel. So, but in order to classify um, the biodiesel as renewable, Vicky, as I recall, the number's like a 30% reduction compared to petroleum, and that I'm going on memory here, and I think that's what the EPA says. That's the margin that you need to call this stuff renewable and get credits for using for either biodiesel or renewable diesel.
In the
So 30%
United States, the blending wall, they call it, is state based, or is it a federal stand? Is there a federal mandate for the
No,
maximum blending?
yeah. So the EPA set levels, the upper levels for ethanol and gasoline. Originally, it was at 10 volume percent. And then the ethanol manufacturers petitioned the EPA back in the early 2000s and got that increased for a reduced set of vehicles. I think it was 2001 and later passenger cars to go to 15 volume percent. And so that's permissible. As far as the diesel goes, the manufacturers, everyone's pretty comfortable at 5 volume percent biodiesel in diesel. Some of the manufacturers are comfortable going to higher levels, as much as 20%, and then some are testing their engines at 100% of biodiesel. And same with heating fuel too. So people are always trying to look at what do we need to do to change the fuel to reduce the carbon impact. And one way to do that is to increase the amount of renewable materials in the fuel itself. And so
And the
that's why
reason,
people,
yeah, and
yeah.
the reason that the blending wall in the United States is relatively low compared to other countries, for example, like Indonesia, um,
Mhm.
for biodiesel. For ethanol, compared to Brazil, which is a sugar producing country, makes sense. Um,
Yes.
the concern really there is that um, maybe the engines today are not ready for 100%. Is that right? That's the main concern. There are challenges in adopting
Absolutely.
100%.
Absolutely. So uh, because both ethanol and biodiesel contain oxygen in the molecule itself, that results in a little bit less energy per gallon compared to ethanol compared to gasoline or diesel fuel compared to excuse me biodiesel compared to diesel. And so the engine designers design the engines to accommodate, like you said, a certain percentage. And if you want to go more, they have to recalibrate the engine. Sometimes they have to change the materials of construction, the metallurgy, or the hoses to accommodate higher percentages of materials that were not the original petroleum fuel that the engine was designed for. So you're absolutely right. There are upper limits before you actually have to make mechanical and physical changes to the engines. That's right.
Yeah. In other words, they're not drop-in fuels. Um,
They're not. They are not. No. As I mentioned,
renewable, yeah,
yeah,
renewable diesel is a drop-in fuel, though, right?
renewable diesel is. It's interesting because we do not have a specification for renewable diesel because it is chemically identical to the same type of hydrocarbons that are in diesel fuel. And the only way we can tell how much renewable diesel versus petroleum diesel we have in the blend is by doing a very expensive carbon isotope analysis. And you look for the differences in carbon isotopes, which tells you the age of the fuel. So seed oil and animal renderings and all that stuff, those are all relatively recent fuels, whereas petroleum fuels have been sitting in the ground for millions of years. And so their carbon isotopes ratios are different. And that's what we can do to tell the difference. But you're right. Renewable diesel is pretty much a drop-in fuel for diesel fuel.
And why is it not catching on like crazy?
Well, there's limitations. There's limitations of the materials that can be used to make renewable diesel in terms of the volumes, in terms of fats, oils, and greases, if you want to call them fog. There is just a limit on the amount of material that you can convert into renewable diesel. Likewise, if you take space in your refinery to make renewable diesel, you have to back out space to make petroleum diesel. And if your refinery is already maxed out in making petroleum-based fuels, you have to actually back out some crude processing to make room for this material, unless you have extra room in your hydrotreater. And so in that case, that gets to be a very expensive proposition to downturn your entire refinery to try to make room to do this renewable stuff. So,
Do you have to add another unit in your refinery to be able to process?
you can do that, but that's a huge capital expense, and people would much rather use their existing units rather than build new. But some folks are building new units, yes.
Yeah, because I remember reading a few months ago, or maybe a year ago, where there was a company that actually bought an old refinery and then was converting it to to produce renewable diesel. But then at some point, they went back to the drawing board and said, no, we're going to go back and process crude, because I guess the economics of renewable diesel wasn't working out for them.
Well, to be blunt, you really need to have the subsidies of the federal government. In other words, your RIN credits, your renewable identification number credits that you get from making renewable diesel. And also, if depending upon the state that you sell it in, for example, in California, they have a low carbon fuel standard, LCFS, which requires refiners to make low carbon fuels. And if you do, you can get credits for that. And so these combination of credits then will make this renewable diesel profitable. But it's the credits that do that. Otherwise, it's more expensive to make that material than it is just to use petroleum.
So let's talk now about, Jim, before we close off on ethanol and biodiesel and your renewable diesel.
Sure.
The key ASTM standards for E10 or E15. The key ASTM standard for biodiesel, and And you said there is no ASTM standard for renewable diesel. I assume it would be the regular ASTM diesel fuel spec that applies to
It is
renewable diesel.
ASTM D975. That's correct.
Okay.
So the standards, Vicky, are really focused on the engine and what does the engine need, rather than being focused on the fuel itself. So what's the minimum performance requirement to make this engine run well? And that's the standard that we write. And so for gasoline, that's D4814, and that covers hydrocarbon gasoline, that covers gasoline ethanol blends up to 15 volume percent. If you want to use a very high ethanol content fuel, that's typically called E85 or sometimes flex fuel. That has a whole different standard. It's D5798, and cars. Some cars are calibrated to run on a high ethanol content fuel called flex fuel, and they're called flex fuel vehicles. And those car owners know that because it's in their owner's manual. Plus, typically, it's on the side of the car, flex fuel vehicle.
How about for biodiesel? What are the key ASTM standards for biodiesel?
So up to 5% biodiesel. That's the same standard as the regular diesel fuel standard. That's ASTM D975, and then we have a standard for biodiesel up to 20% in diesel fuel, and then there's a standard for the pure biodiesel, what we call B100. And so a B5, for example, is 5% biodiesel and diesel. A B10 is 10%. B100, we have a separate standard just for the biodiesel itself to set limits and quality control on that material that we're going to use for blending into diesel fuel.
How about marine fuels, Jim?
Yeah, there were specifications, there were ASTM specifications for marine fuels, Vicky, and I would say that was like 8 to 10 years ago. But since then, the ISO spec has become predominant, and people always make the marine fuel to the ISO specification. And so it was decided by ASTM to retire their marine fuel specification, and people just use that ISO specification now for both the heavy fuel oil marine fuel as well as the resid-based marine fuels.
So I assume then the new fuels, we're talking about ammonia, we're talking about methanol for marine applications. It will also be within the purview of ISO then to develop those specifications?
Oh, good question. Good question. Not necessarily. Specifications can be developed by anyone and any standards body that's recognized. That's a brave new world. We're going to have to look at what do the big marine engines need in terms of quality. If methanol is the fuel, what do they need if ammonia is the fuel? And those will be new specifications. But I think we're in the learning stage as to what those fuel requirements need to be to make those engines work well. And so once we understand that, and people look at the requirements for good fuel, good marine fuel on those products, then we can begin to develop standards.
Yeah. Now let's talk about the challenging, how would you say it? The most challenging I think, for D2 is jet fuel, right? We alluded to that. ASTM has developed 8 pathways, 8 standards for emerging fuels. But it's been a challenge getting those 8 pathways to market. What is the main challenge? Is it the cost of developing the whole another ecosystem to process these fuels, to produce these fuels?
Yeah, Vicky, there's many elements to this. First off, it's a It's a long and careful process to develop these pathways that are approved by ASTM as a standard. And part of that approval process is a multi-step approval by the engine makers. And they have to go and understand the qualities, the properties of these new jet fuels, and sign off on these things. Make sure that they're comfortable going in their engines, and they will deliver the good performance. But why don't we have widespread use of these things? I think we're at the start, and so you're seeing a lot of, I will say, small startup companies trying to get into this space, trying to make synthetic aviation fuel. And just like a startup company, capital is precious. And so they need to get investors, and investors like certainty. And so those are all the things that these new fuels are being challenged with, right? And so I think that's the process. But the governments, especially the EU, has their directives to use a certain percentage of renewable jet fuel, and then increasing amounts as the years go on. And so there's a driving force to manufacture these and get these into the market. But I think Vicki, you hit it on the head. It's cost. These are not cheap to make. We can get petroleum out of the ground, put it in a refinery, and make jet fuel, right? If we want to make these from recycled plastics, we got to gather all these plastics. We got to separate out the plastics that we don't want. We got to grind up the material that we do want. Then we have to process it in a process, depolymerize it, turn it into kind of a chemical soup, and then we have to refine that chemical soup into kerosene hydrocarbons. And then we got to test those hydrocarbons and make sure they meet the spec. And now we can call it a drop-in jet fuel. And so, just from my descriptions, you can tell there's a lot more involved in trying to make these jet fuel products, synthetic jet fuel products, compared to the petroleum-based. But
Yeah,
that's
and
the challenge.
in fact, I think the 8 pathways that have already cleared ASTM and are actually specifications. The maximum blending wall, maximum blending for these fuels, is it 15% or I can't remember what.
Yeah, well, Vicki, it depends. Good engineering answer, it depends. And so the OEMs that review all these materials um, have a certain comfort level, engineering comfort level, when they look at the process and the synthetic jet fuel that's being made. And so in some cases they will allow 5 or 10%. In other cases, up to 50%. And it's like trying to put your toe into a hot bath. You put one toe in at a time, and if things are okay, then you put the rest of your foot in. So it's a careful process, and some of these pathways have different limits. And it's really a matter of being comfortable and having the quality assurance that the fuel is going to perform well every time we put it in a jet engine.
Yeah, now let's talk about Subcommittee P. Traditionally, this has been a small subcommittee, but I think increasingly its role is going to be bigger within ASTM D02 because all of the materials that you mentioned, the alternative feedstocks, these are all really the top kinds of topics that are discussed within P. Talk about P and what it does right now, and what is it looking at in the future?
Sure. So I'll go a little bit back. And the origin of Subcommittee P, which is the D02 main committee, Subcommittee P was focused on recycled petroleum products. So how can we take, for example, used motor oil and used unused fuel that's been sitting around for a while or something, and turning it into useful products, that type of thing. It turns out that that subcommittee P scope has expanded a bit, and now we're looking at other non-petroleum products being turned into hydrocarbons. So liquid fuels, lubricants, that type of thing. And so there's been more interest and consequently more membership in the subcommittee P, and that entire area is growing. And so the subcommittee chairman is Jean-Francois Borny, and he's very busy watching his subcommittee grow and grow and grow. And so that's been the focus of a lot of his activity is task forces, small groups of people that have a particular common interest working on these non-petroleum product pathways to make hydrocarbons, similar to the ones that are focused in jet fuel, but more broadly for all of the hydrocarbon products that we now extract from petroleum. So
pyrolysis oil. Pyrolysis oil. Does it come under the purview of P, or does it come under the purview of Subcommittee J on jet fuel?
So the Subcommittee J on jet fuel is all about aviation fuel, Vicki, and so their focus is really aviation turbine fuel and aviation gasoline. That's the two. Subcommittee P is more broad, and if you're looking at other products from non-petroleum sources, that's typically where that would fall. And so, but there's an interplay between the two, that's for sure.
Yeah. So what are the biggest items on the plate of Subcommittee P at the moment, Jim?
Well, there's several. There's a task force looking at turning plastics into jet fuel. There's a task force that I'm running that is looking at trying to put together what I will call a guide. It's not a specification, but it's really a guide to tell people how does converting some of these non-petroleum materials into hydrocarbons, what are the analyses you should do? What are the compositions you may expect? What are some of the properties? That sort of thing. So it's a guide to try to tell people to get them familiar, because these processes are, they're all brand new. They're technology being developed. You can contrast that with petroleum processes, and we've been working on that stuff for a century. So, brave new world here.
Yeah. So what's the status of this guide now? Is it already does it have a work item number at this point?
It does. It does. We have, so ASTM, when there's a task force working on something, in order to keep track of all these efforts, they assign it a work number. It's a WK number. And our task force is WK 93676. And so that's the one that I'm heading up, and we're meeting on a regular basis to try to advance this guide.
And then once you get to a certain point, you get into ballot, right? You get into the subcommittee ballot or the section ballot or whatever.
When we get our document into a space where we all, and the task force feels comfortable, and we all feel pretty good about what it says and how it's put together, then we bring forth a ballot. The ballot gets voted on by the entire subcommittee. The D02P subcommittee votes on this, and if they like it, it goes forward to the main committee, and then the main committee votes on it again. So it's a very careful process before we issue a document. If anyone, either at the subcommittee level or the main committee level, doesn't like it and they vote negative, that stops the ballot. And then we have to go back and take a look at that negative and talk and work with a negative voter to see if there's an area that we can improve the ballot to address their concern.
I think this guide is going to be very useful around the world, because it's really something that people need to get a working document. I think people are inventing things right now. I mean, now we have a lot of product carbon footprint. This is, I think, an item that ASTM has not been working on. And there's, at least in the lubricant space, several organizations working on it. But definitely, P has a special place in the world to make a big contribution to our industry.
Well, we think so. We think, we think ASTM has a long history of contributions. In terms of the standards that we put together to work well with all of the advanced technology that the OEMs put into their engines. Likewise, ASTM has worked with them, as well as the manufacturers, as well as the regulators and the test labs. We all get together and we try to improve the technology to keep up, so that the engines and the fuels are really a pair. You can't have one without the other, and so you need to work as a system, and it's that systems approach that makes the ASTM products that we make so valuable.
Yeah, Jim, you have had such a long career in our industry. What would be your advice to a young person just getting out of engineering school, chemical engineering graduate? Um, what would your advice be to them? Should they join an industry like ours that I guess is considered mature and not very popular?
Well, no, because that's the way it's often put in the press. But having spent many decades in the industry, and at the point in which there was a severance program placed in front of me, I did not want to retire because I like getting up, going to work. I worked with great people. We worked on things that had a benefit to society. When I drive a car, when I see a truck being, moving materials, when I fly in a plane, I know that our standards were there to make those products fit for purpose and work. And so that's something you can be proud of. And I think, to somebody coming out of school, I would not limit your options with your opinions of the industry based upon others. I would go out, find for yourself, see what you really like to do. I know personally the companies that I worked for, the Amoco and BP that I worked for, there were fantastic people that worked there, and we worked on important things, and we had a lot of fun. And what more could you ask for? I think, and so go out and get your own opinions. Just don't read the stuff that the press puts in front of you and tells you how to think. Go out and find out for yourself, and talk to people that have worked in the industry.
But how can you change the conversation?
How can I change the conversation?
Yes.
Well, I think we do it one person at a time. And like I said, if people would go out and talk to people that have been in the industry, get your opinion of what it's like, and find out for yourself, and then make your own decision. If you come up with a decision that, well, this is somebody I never want to work for, okay, at least you went out and you got the facts and you made your own decision. But if you just go on what other people tell you to think, I would not do that. I would not do that for anything. As a matter of fact, go out and find out for yourself.
So, Jim, any last words?
Any last words? Well, I just want to say thank you. It's been a pleasure, Vicki, talking to you and seeing you at the ASTM meetings many years. And I wish you the best. And thanks for this opportunity. Appreciate it.
Well, thank you so much for your time, Jim, and your expertise. And we look forward to the next meeting in June.
Me too, Vicki. I'll see you in Kansas City.
Thank you. Take care. Have a great day.
You too.